what are the restrictions on B so that X has two solutions in this given equation? Okay, let us try to solve this equation for X. Okay, here on the left side of the equation, we have addition of two logarithms with the same base B. So here we can use the product rule of logarithm, that is -1 positive. Whenever two logarithms are in addition with the same base, what we can do is we can write the logarithm once with the base what we have, and we can multiply the arguments. So when I multiply a and 2 plus x, it will be a times 2 positive x is equal to log a over 2 negative x to the base b. Okay, we can write this -1 next to this logarithm. So we get log a times 2 positive x to the base b, -1 is equal to log a over 2 negative x to the base b. Okay, if I want to combine this logarithm and this one, I need to write this one in terms of logarithm with base b, because for this logarithm we have the base b. If I'm able to write this one in terms of a logarithm with the base b, I'll be able to combine the two logarithms. So log a times 2 positive x to the base b negative. So I can write this one as log b to the base b, because in any logarithm, if the argument and base are same, the value of such logarithm is 1. So instead of 1, we can write this log b to the base b is equal to log a over 2 negative x to the base b. Okay, now these two logarithms are in subtraction. We can use the quotient rule. Whenever two logarithms are in subtraction, we can write the logarithm once. We can divide the arguments, that is a times 2 positive x over b equals to log a over 2 negative x to the base b. Here, the two logarithms are equal, this one and this one. So the base of the logarithm on the left side is b, the base of the logarithm on the right side is also b. Whenever two logarithms are equal with the same base, what we can do is we can equate the arguments. That is a times 2 positive x over b is equal to a over 2 negative x. That we can do it on the next page. A times 2 positive x over b equals to a over 2 negative x. Okay, now what we can do is we can do cross multiplication. That is, this numerator can be multiplied by this denominator. This numerator can be multiplied by this denominator. When I do it, so I'll be getting a times 2 positive x times 2 negative x is equal to a times b. Okay, now I divide both sides by a because both of them are multiples of a. So a will cancel out. Here a will cancel out. I get 2 positive x times 2 negative x is equal to b. Okay, so now this is in the form of a plus b times a negative b. Already we know the algebraic identity, that is a positive b times a negative b is equal to a square negative b square. So for this, what we can write is 2 square negative x square is equal to b. So 2 square is 4, negative x square is equal to b. Okay, my aim is to solve for x. So I subtract 4 from both sides. So 4 and negative 4 will cancel out. I get negative x square is equal to b negative 4. Now I multiply both sides by -1 to get rid of this negative sign. So -1 times negative x square is equal to -1 times b negative 4. So negative times negative will become positive. 1 times x square is x square. And when I distribute this -1 to this b and -4, I'll be getting negative b, positive 4. Otherwise, we can write as 4 negative b. Okay, now to get rid of this square, I need to take square root on both sides. So the square root and square will cancel out. Whenever I take square root on both sides of an equation, on one of the sides, I have to take positive or negative sign. So I am taking positive or negative sign for this one. So it will be positive or negative square root of 4 negative b. Okay, I have solved for x. Now, I must get two solutions for x because that's a condition given in the question. Okay, one more thing is here we have square root. Inside the square root, if the value is negative, it will be considered as imaginary. If I want to get a real solution for x, So the value here inside, that is 4 negative b, has to be either 0 or greater than 0. That is 4 negative b is greater than or equal to 0. Okay, here we have two options. One is 4 negative b is greater than 0 and 4 negative b is equal to 0. What if 4 negative b is equal to 0? We get x is equal to positive or negative square root of 0. Then we get x is equal to square root of 0 is 0 and the sign now matters for 0. So we get x is equal to 0. When 4 negative b is equal to 0, we get only one real solution for x, that is x is equal to 0. But according to the question, we must get two solutions for x. So we can reject this option 4 negative b is equal to 0 and we can consider only 4 negative b greater than 0. Okay, let's try the first option, that is 4 negative b is greater than 0. Let's say 4 negative b is equal to 1. So because 1 is the value which is greater than 0, so then we get x is equal to positive or negative square root of 1. We get x is equal to positive or negative square root of 1 is just 1. So we get two real values for x, 1, negative 1. So when 4 negative b is greater than 0, we get two solutions for x. So that's the condition given in the question. So if I want to get two solutions for x, 4 negative b must be greater than 0. Okay, now let's solve for b. So I'm adding b to both sides. I get 4 greater than b, or it can be written as b has to be less than 4. So if I take any value for b which is less than 4, then I'll have two solutions for x. So the restrictions for the values of b is b has to be less than 4.